Yeah, in the next exercise, our next exercise is limit, and this is, x approaches to 0, or 1 plus sine x, 1 plus sine x, and raised to the power cot x, raised to the power, it is cot x. Okay, cot x. So the similar method we will use. We will let it is equal to y. Okay, let y is equal to 1 plus sine x raised to the power cot x. Okay, and taking natural log and also limit x approaches to 0, natural limit x approaches to 0, natural log of y is equal to limit x approaches to 0, natural log of 1 plus sine x, and raised to the power cot x. Okay, now cot x. Okay, now what we will do, according to the property of log, we can write limit x approaches to 0, cot x we can write before natural log by the property of log 1 plus sine x. Okay, and now we know that this is equal to limit x approaches to 0, and cot x, and this will be 10x when we convert it into the it will be 10x when we convert into it is natural log of 1 plus sine x, and shift the cot x in the denominator, it will be 10x after shifting into denominator. Okay, now suppose if I put limit x approaches to 0, so after putting the limit x approaches to 0, sine 0 is, this will be 0, and 1 plus 0 is 1, and natural log of 1 is 0. Also tan 0 is 0, tan 0 is 0. So in the numerator and in the denominator we get 0 and 0. So this is 0, this is 0 divided by 0 form, or this is also called indeterminate form. When we get an indeterminate form, then it means that we apply the L'Hopital rule. We take the derivative of the numerator terms and the denominator terms. Okay, so what are the derivative of natural log of 1 plus sine x? The derivative of limit x approaches to 0, derivative of natural log of 1 plus sine x, it is 1 over 1 plus sine x, and the derivative of sine is cos x, divided by the derivative of tan x, it is secant square x, it is secant square x. Okay, now this is equal to limit x approaches to 0, cos x divided by 1 plus sine x, and when we convert secant square in the above, it will be secant square, it will be cos cube x. Okay, secant square x, it will be when we shift this into above, it will be multiplied by cos square x, and this will be equal to limit x approaches to 0, so this is cos cube x divided by 1 plus sine x, and now it is not indeterminate form. It is not indeterminate form. So now we will not apply the L'Hopital Hospital rule. We will apply the direct limit. After applying the direct limit, cos 0 means 1, 1 plus 0, sin 0 is 0, so it is equal to 1. So but our left hand side was what? It was limit. It was limit x approaches to 0, natural log of y is equal to 1, and limit x approaches to 0 and y is equal to e raised to the power 1. So limit x approaches to 0. What we let about y? What was y? It was 1 plus sin x raised to the power cot x. Raised to the power cot x is equal to e. This is our answer of this question. Okay, let me take a short look of this question. How would you do it? How we do it? Okay, now clear this page, and now we will do another exercise. In this exercise, our limit is x approaches to pi by 2, x approaches to pi by 2, and secant x raised to the power cot x. Secant x raised to the power cot x. Okay, again the same method we will use. We will let it is equal to y. Let this is equal to y. Let y is equal to secant x raised to the power cot x, and taking the derivative on both sides, taking the natural log on both sides, natural log y is equal to natural log of y and natural log of secant x raised to the power cot x. Okay, by the property of log, we can write cot before natural log. It is equal to cot x and natural log of secant x. Okay, so cot x and it is natural log of y. So our limit is x approaches to 0, natural log of y is equal to limit x approaches to 0, and we can write it is natural log of secant x, and cot x will be tan x in the denominator. Okay, now if I put the limit x approaches to 0, and secant 0 is 0, so natural log of 0 is infinity. Yeah, this is secant 0 is 1. Secant 0 is 1 over cos 0, it is 1, and natural log of 1 is tan 0. No, the limit is our limit in this question is pi by 2. The limit is pi by 2. Since the limit is pi by 2, then 1 over cos pi by 2. 1 over cos pi by 2 here. 1 over cos pi by 2 it is, cos pi by 2 is 0. So 1 over 0 means infinity, and natural log of infinity is infinity. 1 over cos pi by 2, 0. Cos pi by 2 means 0, and 1 over 0 means infinity, and natural log of it means, in this question, in this question, tan pi by 2, which form this is? This is infinity divided by infinity form. Since this is infinity divided by infinity form, so what we will do to remove this form, infinity divided by infinity form, we will apply the L'Hopital hospital rule. So what is the derivative of natural log of secant x? It is limit x approaches to pi by 2, and 1 over secant x, and derivative of secant x is secant x into tan x, divided by the natural log of tan x is secant square x. Secant x is cancelled out with secant x, and we get what we get. It is limit x approaches to pi by 2, and in the numerator only one term, which is tan x, and it is secant square x. So when x approaches to pi by 2, tan pi by 2 infinity, it is again infinity divided by infinity form. Which form? Infinity divided by infinity form means indeterminate form. So in case of indeterminate form, what we do, we apply the limit L'Hopital hospital rule. X approaches to pi by 2, and the derivative of tan x is secant square x, and the derivative of secant square x is 2 secant x, and secant x into tan x, secant x into, so secant square x is cancelled out with secant square. It will be 1 over tan 2x, 1 over tan 2x. Okay, 1 over tan 2x. This will be equal to limit x approaches to pi by 2, and this is 1 over 2 tan x, and tan x is again infinity, and 1 over infinity is, when we apply the limit, we get 1 over infinity, which is equal to 0. And our left hand side was natural log of y. Limit x approaches to 0, natural log of y is equal to this 0. Okay, and limit y x approaches to 0 is equal to e raised to the power 0, which is equal to 1. So this is our answer.